Hello everyone, my name is Mr. McGregor, and in this video we're going to be looking at speed. By the end of this video,
you'll be able to define the term speed,
use formulae to
calculate speed, distance and time, and state the SI
distance,
units for speed, distance and time.
So speed is a measure of how fast something is moving, and we all know that some objects move faster than others. The Formula 1 car, for example, moves significantly faster than the snail. There are three things of interest here. Firstly, the speed itself. Secondly, the distance the object has travelled. And thirdly, the time it took. And when we put those three things together, we get the speed equation. Speed is equal to the change in distance over the change in time. Or as it's written there in symbols, v, which is the speed in meters per second, is equal to the change, which is that little triangle, in d, which stands for distance, over the change in time t. And we can see there too the units, meters per second, which you can write in one of two ways, meters for distance and seconds for time. So we're going to look at two examples. Firstly, Usain Bolt, the fastest human over 100 meters, and a cheetah, one of the fastest animals on the African plains. Usain travels 100 meters in 9.58 seconds, while the cheetah travels 500 meters in 16.6 seconds. Now if you just look at the times, it looks like Usain is faster. However, of course, he's running a shorter distance. So therefore we use our speed equation. So our first step is always to match the numbers we've been given up with the things that go in our equation. So in this case, the d is 100 meters, and the t is 9.58 seconds. We're of course trying to find the speed v. We use our speed equation, v equals d over t. We put in the numbers, v equals 100 divided by 9.58. Chuck that into a calculator and you get an answer of 10.4 meters per second for Usain. Do the same for the cheetah. Plug it into our equation. Put those numbers into your calculator. And you see we get 30 meters per second for the cheetah, which means the cheetah is in fact going about 3 times faster than Usain. Now a cheetah can't actually run at that speed for very long, but let's just pretend here that the cheetah could maintain that speed for the full hour, and let's see how far the cheetah would go in an hour. So we have the speed there, 30.1 meters per second, and the time of 1 hour. But now if you recall, our time needs to be in seconds, so before we go too much further, let's turn that into seconds. We take the 1 hour, we multiply it by 60 to turn it into minutes, because there are 60 minutes in an hour, and we multiply it by 60 again to turn it into seconds, because there are 60 seconds in a minute. And we get the answer there of 3,600 seconds. We need to use that number for the rest of our calculations. In this case, we're trying to find the distance. Now, so far we haven't actually had an equation for distance, so we need to rearrange our original speed equation. If you're good at algebra, you can do that pretty easily. But for those of you who aren't, we're going to use the magic triangle. And the way this works is you simply cover up what you're trying to find. So here we can put our finger over the d, and we're left with v times t. And so that is the form of our equation, d equals v times t. And once you've done that, it's simply a case of substituting in your values. 30.1 times 3,600 gives you a distance of 108,360 meters, which is about 108 kilometers. And that means that the cheetah is going slightly above our speed limit here in New Zealand, travelling 108 kilometers in the hour. Now let's imagine that for some random reason that cheetah wanted to get from Christchurch to Greymouth, and let's just pretend that it could travel at that same speed of 30.1 meters per second the whole way. We can see from the map that the distance is 244 kilometers, which is the same as 244,000 meters, and we need to use the meters value in our calculations. And in this case we're trying to find the time. If we use our magic triangle, cover up the time, we see that it is equal to the distance divided by the velocity. And it is important once again that that distance goes first. Whatever is on top of the magic triangle must go before the division sign. If we plug in those numbers, we get a time of 8,106 seconds. Divide that by 60 and we get 135 minutes. Divide that by 60 again and we get 2 hours and 15 minutes. Quite a bit faster than it would be to go by car.